Okay, so first of all, we will get to know about the ultrasonic sensor. So, ultrasonic sensor has four ports here. You can see in the picture that it has VCC, trigger, echo, and ground. So, this is the ultrasonic sensor, and this model HC-ASR04 is very common model for the ultrasonic sensor, and it has a maximum range of 4 meter in order to measure of the distance. So uh, we actually use this sensor to measure the distance and like these things. So we move forward. So this was the sensor, and this is the uh, four ports. Let's go forward. So this is the Arduino board, Arduino Uno, and okay, this is the connection. I make it bigger. Okay. So this is the connection. This is simple. Simply, it is saying that 910, 5-volt ground. So what they did is they directly connected the VCC to the 5-volt, the ground to ground. It's a simple rule, ground to ground and VCC to 5-volt. It's a very simple wiring, and this to echo and trigger is connected to 9 and 10 ports. So if you want to change these ports, you can also do it. So I move forward. This is the specification: operating voltage, operating current, operating frequency 40 kilohertz, maximum minimum range 2 centimeter or 1 inch. Okay, so this one 2 centimeter or 1 inch, when we test it, we will see that 2 centimeter and 1 inch. If we measure the distance within this range, it will show out of range or error. So the maximum range I already said 400 centimeter or 13 feet. The accuracy is 3 millimeter. Measuring angle 15 degree. Dimension 45 into 20 into 15 mm. So move forward. So this is the calculation. Those who don't want to listen the calculation of mathematics also can. And so this is just for experiment. Receiver pulse duration time we give 1.5 millisecond, and speed of sound we give 13. Speed of sound or speed we give 340 or 34 centimeter per second. So the calculation is distance equal to speed into time divided by 2, or so this equation come 34 got from here and 1.5, and it become 25.5. Let's say echo pin was high for 2 meter second. So if we want to get the distance in result in centimeter, we can convert the speed of sound value from 30 meter per second into 34 centimeter per second, centimeter per millisecond. So we can see it is 25.5 centimeters. So this is the very simple logic of sound which you can measure the distance man. Let's move forward to the wiring part with Arduino and ultrasonic sensor. So let's come forward to the next part. So this is the ultrasonic sensor, this is the breadboard, this is the Arduino Uno. So now we will learn that how I connected. So let's see that it has 4 ports. You can see VCC ground, and 4 ports: VCC ground, trigger and echo. You can see VCC ground, trigger and echo. Okay, so in the very small, right, you can see here ground, echo. So now we are connecting these 4 ports. So first of all, we have ground. So ground, this one black one goes to the minus part, so this one is the minus, plus, minus, plus. So this ground directly goes to this minus, the black one. Then we got trigger and echo, the middle two, this middle two, the green and blue, this green two. So for this experiment I have given these 2 ports to number 10 and number 13. You can see here green and blue is at number 10 and number 13. It is number 10, the green one, and this one is 13. You can see now. So this was the connection, and you can see this is the red one is the VCC. So VCC I connected to plus portion, and then you can ask why plus portion. So then I directly give the connection to this red one, red, to 5 volt. You can see, wait, I will see. You can see 5 volt here, the red connection. Let's not go to the distance measurement part. This is the distance measurement part in the in the PC or desktop monitor, not by this one. I will tell how we configure this one with these wires. So first of all, we have to do this thing at first to. So I recap again that you can see this one is the ground. I connected it to this one, black one, minus part, and then minus part is another black one. Then I again black one I give to ground. You can see ground, black. So same thing. Then this is the VCC I connected to 5 volt. Here I give connection, and then I just adjust it with the red wire to the, you can see here 5 volt. Okay, this is the 5 volt. So again, this is the blue one, and the green one is the trigger and echo pin, and I give the connection to number 10 and 13. You can see number 10 and 13, the blue and the green one. You can give to any port as your wish. And already said about the ground. So this was the just ultrasonic sensor, and the ultrasonic sensor I fitted in on the plus portion, you can see. Yeah, and then I give the connection. So when you give the connection right here, the ultrasonic sensor will start to work. I will show how it will start to work, but again I want to say that how I connected the distance measurement display. This is the display, so it is just showing. I'm not saying anything, I'm just saying how I connected. So you can see it has also same, it has one ground, one VCC, one HDA, and one SCL. So this the blue one, you can see ground will go to ground. The blue one, this one, blue goes to the ground. You can see here is a ground. The blue one, this is the blue one, it goes to the ground. Okay, so VCC is the green one. You can see green one will go to the 5 volt. You can see the green one going to 5 volt, not 3.3 volt, 5 volt. Okay, so SDA and SCL. So we have SDA and SCL here. So you can see that in Arduino Uno there are 2 ports, is SDA and SCL. So it's very simple wiring, just yellow one and this one. We directly connected it to the SCL and SDA port, just connecting this one. After that I will go to the coding part, that how I connected this one. So this was all for the connections. It's very simple with this one and this one. This one is very simple, just connected to VCC. VCC connected to 5 volt, ground to ground, SDA to SDA in the Arduino port, SCL to SCL in the Arduino port. It's very simple. Okay, so this was the coding part. So I move forward to the coding part. So I have to see this, I have to add two libraries here, include wire.h and include liquid crystal.i2c.h. So this one you have to add the library, because without this the code will not run. I faced a lot of problem during this because this library I couldn't find. So I show you how to find. You go to file, not file, you have to go to sketch, then you have to give include library. Then if you want to if you want to download this library from the internet, you can do this and add .zip in the library, or you can search from here, or you can see manage libraries. Okay, so when you manage libraries, if you search this one liquid crystal.h, so if you search this one, you can see this one, it is already here. So you will just click on install and it will be installed. I already installed it, so no need to install for me now. So I go to the next part. So this was the liquid crystal I2C LCD 0 plus 2762. So here you can see adjust the address and LCD dimension as needed. So as Arduino is following the C language, so you can see the LCD gives a size, so all the LCD has not the same size. So you have to see your display or LCD that what size it belongs to. So you have to give correct to this one. This one is the common one, so I think it will not work for every device. So you have to see what device you have. So this is the common one. So for this I already defined two things here to define trigger pin and echo pin, which is 10 and 13. And this was the common one. Serial begin 9600. So I give pin mode, trigger pin as output here, and echo pin as input. So you can see that LCD.init, I initialize the LCD. This is the syntax. Then LCD.backlight for turn on the LCD backlight. So then here I will call a loop. So I give float duration and distance, so we will measure it on float. So I declare it as float. Then digital write trig pin low, and then delay for micro 2 seconds. And then again the trigger pin is high, delay for micro 10 seconds. This is how, and we have to measure the distance using duration divided by 2 into 0.0344. So I give a if and else else condition here. If the distance is greater or equal 400, you can set it to anything like 800 or something like that. Distance is less than equal to LCD.clear, the LCD will clear the display, or it will print it will print out of range. If you can see this is AND operator, so it will both have true, otherwise the distance will say out of range. Else it will show the actual distance in centimeter. You can see distance, LCD.print distance, and LCD.print cm. Then again delay for 500, delay 500. So this was the code. If anyone want it, I can give the code. So this was very simple code, I guess. And I already say about the AND operator. Okay, so that's it from the code part. I already told about this one and dimension. That's it. So now I will tell more about one more part, because previously we have shown you guys that this is the serial monitor which I will run in my PC. Then it will do like this. It is changing time by time, you can see. But what if you want to display on LCD and display on serial port both? So if you want to do these both, you have to do some changes in your code. So you can see that if you want to display on serial monitor, you give like this. All these are same. So first you have to give serial, and here you have to give LCD, and here the difference you have to set the cursor 0 to 0. So this is how it will print, and almost all the things are same. So that's the thing I wanted to let you know. So let's see next that it is both working or not, like in the serial monitor and also in the LCD monitor. Let's see. So now let's see it works on both display and LCD or not. So you can see that 1010 at 1010 the distance is 156.45, so it already go up. We can see here is also 156.02, here is also 156.02 is going on. So it's working on both monitor and it is the same. So it's the same with this and this. So that's it, my friends, that's all. You can see it working on both, so that's good. When you want to do on both, like monitor and the LCD, you have to do coding like this one. All these things are same, just change this one, and I will upload the code in the description. That's it. So now let's move on. When we run the code, so first we have to do here, from here to verify, then you have to run. Then when we run the code, we can see that it is now 10:07 a.m. and here also 10:07. Delaying time and distance, it is distance 156. So now it is 156 because there is no obstacle, you see. So if I give a obstacle here, you can see it will change 9.444466. So you can see it is changing. I am trying, you see, 764. So if I move more forward like this, you can see it will become bigger. So it's working, right? That's good. So it's working.